Okay, finish about the rainfall intensity and also the estimation of the rainfall. So now we go to the last section is beyond hazard map, which is risk maps. So what is flood? What is the flood risk? Okay, basically these two terms have been different. Okay, floods. Okay, you tahu lah. There is a flood. There is an increase of the water level over the river, and some case the water level increase sehingga dia melimpah keluar ke kawasan yang rendah. So terjadilah we call as the floods. And then for the flood risk, there is a risk that due to the flood, risiko banjir. So how we reduce the flood risk? Okay, last time, if we want to reduce the flood risk, we try to do some flood mitigations. Okay, maksudnya we propose the new channel, or probably you propose a new detention pond, to reduce the floods. But now that method actually is not very successful to managing the floods. Okay, the flood will be occur. So that's why we have the another method, which is a flood control. Okay, you control the floods. Okay, that's mean you instruct some instrument, some hydrological structures to overcome the floods. Okay, the concept actually is quite similar like the flood mitigation. Okay, that's mean flood mitigation we try to adapt, and then for the flood control we try to control the flood, and then still the flood or this hazard cannot be solved 100%. That's why we go to the another method, which is we have the flood management. That means we try to manage the floods. Okay, so to manage the floods, we have two type of measurement. The first is structural measures. The first is structural measures, and the second is non-structural measures. For the structural measures, actually you construct some structure on the site. Okay, for example, you build up the barrage. Okay, you have tidal gates, flap gates, and locks. Okay, this one is a regulate water level. And then we try to store and control the release of flood water, by have the dam reservoir, detention pond, and etc. Okay, so this figure, as you can see, on normal day, you can see this is the main river, and then this is the resident area. During the flood, you can see most of the area of the resident have been submerged, tenggelam dengan air, banjir. There is a flood occurs. So how to control this one? Okay, so the traditional method, which is mitigate and also the flood control, we can deepening and widening the channel. Okay, but still, if we widening and deepening the channel, there is a possibility of the flood will be occur. Probably due to the sediment erosion. Sebab sungai ni muka bentuk dia selalu berubah. Maksudnya bila kita dalamkan lagi, dalam certain masa dia akan cetek balik. Because that one is a natural phenomena, because due to the erosion, daripada sedimen. And then beside the area, you can see kawasan ni sebenarnya kawasan yang kita panggil floodplain. Kawasan dataran banjir. Di mana bila air sungai naik, Okay, dataran banjir ini atau floodplain, okay, will be flood first. Memang kawasan tu akan banjir. So, dengan cara lain untuk tackle this problem, okay, kita dalamkan sungai. Ataupun kita construct the bund. Okay, that's mean you increase. Maksudnya you tinggikan sungai tu. So yes, this one can reduce the flood. Okay, tapi this one actually is not a permanent. Okay, what happen if the bund have been broken? Okay, bila bund pecah, apa jadi? So air ni akan mengalir masuk ke dalam sungai, ke dalam kawasan resident area balik. So this one actually is not cannot settle 100% the flood from the occurred. So reason for this situation because kawasan floodplain actually there is a high risk of the flood being occurs. So to overcome this area high risk, okay, we need to probably reallocate the people, okay, from that area. Yalah, bila kita mungkin orang akan marah lah dengan statement ni. Kenapa kena pindah? Okay, rumah saya dah bertahun-tahun dekat sini. Selama ni tak pernah banjir. Tiba-tiba banjir. So, bila kita selidik, bila kita tengok sebenarnya kawasan yang diduduki oleh orang ramai itu sebenarnya kawasan dataran banjir. Mungkin ada salah pembangunan ke. So most of this area actually is very valuable dan banyak rumah lah dekat kawasan dataran banjir. So untuk overcome risiko banjir, sepatutnya kawasan tersebut tak perlu dibangunkan. Tapi benda tu berlaku sebab mungkin saya tak nak komen lah lebih-lebih. Bahaya komen lebih-lebih, takut kena tangkap pula kan. So okay, so we can see at the right side, okay, you ada this channel, and then this channel there is a flood. Okay, to overcome that, probably we can divert like this one. So tak adalah lagi banjir dekat kawasan ni. Ataupun you make some sort of the detention pond here, okay, and then you put some pump. So when there is some certain level of the water, okay, the pump will be operate and will be stored at the detention pond. And then after certain period, okay, air itu akan mengalir balik ke main sungai. So kawasan yang at the downstream, okay, of this area, okay, will not being floods. Okay, this one you can see we make a bund or flood wall. Okay, we have this area, okay, this one is main river, okay, this one main river, this one river, and then at certain level, okay, bila air limpah, so ia akan masuk ke kawasan perumahan, kawasan dataran banjir, the plain flood. Okay, and then we build the bund or the flood wall. Okay, this one bund. Okay, so the flood is not occur. What happen if the water level of the river is increased? So you can see probably the bund or the wall will be break, okay, and it will increase the flood risk over this area. So that's one we don't want that thing to happen. So to mitigate this problem, so we can follow an idea, some sort. If we don't want our area have been flood, okay, the area that have a high risk of the flood, for example, this resident, okay, probably this resident need to be allocated to another area which not being risk with the flood. Okay, so sepatutnya masyarakat tu kena pindah lah, kena bina lah satu kawasan perumahan ke rumah pangsa ke yang boleh allocate all this resident area, okay, dekat kawasan yang bukan dalam dataran banjir tersebut. Mungkin kawasan dataran banjir, okay, seperti yang sini, okay, kawasan dataran banjir, the floodplain, okay, we can construct some facilities macam contoh for recreation, okay, you boleh make a football ke, which is when the flood is occur, okay, kawasan padang tu je yang tenggelam. So you reduce the flood risk, okay, from occurs. Okay, the flood will be occurs, okay, tapi kesan kepada masyarakat kita boleh reduce, okay, by allocate the people. And then as you can see from this table, okay, the expenses for the terbatan banjir, okay, to mitigate the flood actually have been increased by years. Okay, kalau you tengok from 1971 to 2000, okay, the expenses for the flood is around 1.6 billion, and then the most recent one, 2006 until 2010, is almost 3.834 billion. So the costs have been increased by time. So that's why we have another measurement, which is a non-structural measures. Okay, we have a floodplain management, we have a flood mapping, land use mapping, educational and awareness, development control, flood forecasting and warning, and flood response and recovery. So from here you can see all this thing actually is a disaster risk reduction and management. Okay, sama macam you guys punya master of disaster risk management. Ni reason kenapa you belajar. Okay, so non-structural measures. So kalau you lihat macam di negara-negara Jepun, for example in Japan, okay, normally for the area along the floodplain, you can see there is no development. Okay, no development. So you tengok ni ada macam padang untuk orang recreation ni. Kalau you tengok cerita macam for example Doraemon lah kan, so dekat tepi sungai, dekat situlah kanak-kanak main bola, okay, and then you nampak macam tempat kawasan floodplain ni, okay, kawasan yang rendah. Bila dekat kawasan bila budak-budak nak naik atas, okay, dia kena naik tangga nak naik atas. Okay, so you can see, okay, kawasan tersebut adalah dataran banjir. Okay, dan saya rasa Jepun pun mengambil masa lah untuk allocate all their resident area, okay, to other places. Okay, same like us lah. If we want to tackle the flood problem, okay, we need to reduce the risk. Okay, one of the risks is about the population. We need to remove all the population from the floodplain area to another place which at the high level. Okay, so you can see this one, sungai, okay, river and floodplain in Japan. Tengok, orang beriadah dekat kawasan floodplain ni. Orang tak tinggal kat sini because when there is a heavy rain, okay, this area actually will be covered with the water. Okay, the flood will be occur. So I think this one is much better as compared if you build a barn, if you lebarkan sungai, still the problem still be occur. So this is the example of the risk map that being produced if we simulate by the hydrology and the hydrodynamical modeling. So you can see we can know which location or which area that have a high risk, which is the occurrence of the flood will be higher. Okay, kawasan yang tinggi terkena banjir. Okay, kalau you tengok yang biru-biru ni memang kawasan yang high risk lah. And then yang macam biru cair ni, okay, kawasan yang kurang berisiko tapi still banjir akan berlaku. So this is example how we propose the hydrological, the structural and non-structural measures. Okay, so as you can see, okay, this one is the line of the river. For example, the Kampung Bahu. Okay, kawasan ni kawasan yang banjir. So the consultant have been suggest to allocate the resident area is around 3 acre, contain 10 houses to another place. Okay, and then for this area, okay, Felda Cerul dekat Pahang. Okay, kawasan ni memang kawasan yang padat. Okay, if we want to allocate the resident, probably it will increase the cost. So the consultant suggests to propose a new band, okay, for 3 kilometers. Okay, so the house that affect with this new band is almost 160 houses. Okay, if we want to allocate to other place, probably it will be increased lah. So we suggest to have the band. So that's how we tackle the flood problem. Okay, so finish about the risk in the flood. So and then we go to the risk analysis in the context of the natural disaster. So risk management actually is we identify and then we assess and prioritize the risk. Okay, because the effect of the uncertainty of object, whether it's a positive or negative. So risk can be occurs, okay, and also come from a lot of the factors. For example, financial markets, threats from the project failure, okay, legal liabilities, and etc. So there is many factors that can influence to the risk. So to calculate the disaster risk, okay, we have this formula, which is H is the hazard, okay, in terms of the magnitude, frequency, severity, severity, and then we have the E. E is the exposure. Okay, exposure something like population. Okay, population of the resident, and then the asset. Okay, like house, like the shop, commercial area, and then we have the landscape, and then we have the V times with the vulnerability. Okay, something like the age. Okay, age of the people, gender, health, knowledge, awareness, and preparedness. and then divide with the countermeasure. Countermeasure something that we build some infrastructure, or we have the early warning system and hazard risk map, and etc. If we want to develop the disaster risk index, okay, we need to have a various component, okay, in terms of the H, E, V, and C. So the component have been identified through the four main factors, okay, related to natural, social, and economic, and then institutional, and also the physicals. So all factors have their criteria components, which will be quantified and given specific index and score. Okay, all score can be categorized to represent the hazard, vulnerability, or capacity, and the risk will be then calculated based on the categories components. So this is the component. We have variety of the components. So if we want to provide the index for the DR, okay, disaster risk, okay, we need to have this score. Okay, for example, for the age. So for the age, okay, 25 to 35. Okay, you can see their age is less vulnerable. Okay, kalau umur 25 hingga 35 ni, okay, contoh kalau banjir berlaku, okay, these people actually is less effect to the flood. Okay, mungkin dia boleh berlari keluar, okay, cari tempat perlindungan. Okay, and then kalau umur meningkat, okay, daripada 36 hingga 45, you can see is least vulnerable. Tapi pakcik-pakcik ni masih mampu lagi mencari tempat lah. 36, 45 umur macam saya kan, masih boleh mencari tempat lagi untuk berlindung. Okay, and then we can see 0 until 10, okay, and then greater than 70, okay. These people actually is very vulnerable. Can you imagine the kid, kan? Memang kalau tak ada sesiapa yang guide mereka, memang very vulnerable. So that's how we classify and score, okay, the criteria. And this score actually based on the literature review and also from the interview. So if we want to reduce the disaster risk, okay, we look with the disaster risk formula, which is this one. Okay, we have H, hazard. We have E is the exposure. We have the vulnerability, and then we have a countermeasure. So if we have the hazard, and then we have some countermeasure to tackle it. For example, if there is a hazard, okay, we build some infrastructure to control or mitigate the hazard. Okay, so what will happen? Okay, you try to reduce the hazard. Okay, you imagine if we have if we greater the value, okay, this side, okay, your DR will be decreased. Okay, similar by the exposure, which is concentration of people and asset. If we have the countermeasure, we try to reallocate, okay, those people, okay, from the hazard areas. For example, we try to move them to a high area, and then probably they buy some insurance. Okay, they have an insurance, so probably if there is a flood occurs, okay, the insurance will be cover their loss. And then for the vulnerability, which is behavior and attitude of people, if we have some if we raising some awareness and preparedness for the local people, okay, we can reduce the disaster risk. So this is how we want to tackle the and try to reduce the disaster risk. So for the Malaysia, if we look about the Malaysia, okay, we have the government agency, which is National Disaster Management Agency, or we call as a NADMA. NADMA ni nowadays agak popular lah. And normally for the NADMA, okay, they try to have collaboration with others agency. Okay, bukan NADMA sahaja yang tengok kepada risiko ni. Okay, semua jabatan kerajaan, okay, yang terlibat, misalnya JPS, Polis, JKR, okay. So all these government agency actually, okay, try to collaborate and try to manage of this disaster risk. Okay, as I mentioned before, Malaysia normally kalau kita cakap bencana, okay, kita akan lihat in term of the banjir. Kalau untuk banjir, and then there is a landslide before this. Okay, landslide pada 1GKR. Okay, normally the problem is landslide. This two fenomena yang sering berlaku dekat Malaysia. So people, the agency yang suppose yang turun padang, okay, untuk lihat benda ni adalah NADMA. Tapi baru-baru ni pun banjir dekat Selangor hari tu pun ada juga isu lah. Problem dekat Malaysia ni sebenarnya banyak agensi yang bertindih. Bila terjadi sesuatu, okay, tak ada siapa yang ambil tanggungjawab. Saya cakap ni bahaya ni dalam rekod kan. Tapi kita nak cakap gambaran macam tu lah. Bila banjir, okay, orang akan salahkan NADMA. And that one NADMA kata kami tiada kuasa. Lepas tu NADMA kata, okay, JPS salah. Lepas tu JPS kata kami bukan tengok pada risk, okay, kami just bina infrastruktur. Ini salah yang ni, ini salah yang ni. At the end, nobody want to take this responsible. So this is happen in Malaysia. Okay, so this is the summary of the DRM, disaster risk management cycles. So we have the pre-disaster and post-disaster. So for the pre-disaster, we try to prevent, and also we want to mitigate the hazard before it's happened. Okay, and then for the post-disaster is in terms of the preparedness, and then we have the response, and then the recovery. So you tengok, tak semua agensi yang terlibat dengan semua circle of the DRM. And as you can see, for the NADMA, okay, they suppose contribute to all cycles of the DRM. For Army, okay, Army dia tak tengok in term of the pre-disaster. Maksudnya Army dia tak ada tengok projection ke, projection hujan ke, projection banjir. Dia tak tengok benda tu. Tapi benda tu sepatutnya orang NADMA kena tahulah. So bagaimana NADMA kena tahu? Dia kena refer to others authorities lain. For example, if we look in terms of the flood, okay, normally flood is related with the rainfall. So normally rainfall, okay, we can refer the data from the JPS. Okay, tapi the JPS punya data actually is not real time. Normally is a log. That's mean that data will be keep, okay, and then it take time to process. But for the real data, okay, for the rainfall, okay, we can obtain and look based on the, data from the satellite, data from the radar, okay, which is more real. And this data normally we can access from the Jabatan Meteorologi. Okay, so suppose Jabatan Meteorologi and the NADMA need to collaborate to each other. If they found there is a heavy rainfall occur on this place, and then they also Jabatan Meteorologi also they have some simulation that can project 2 days of the rainfall. Ada teknologi sebenarnya Jabatan Meteorologi boleh project. So if they know okay what happened in the 2 days rainfall, for example, so probably they can remind and alert the NADMA or others authorities. So at least others authorities can be prepared and try to respond the hazard that be occur. And then this one, you tengok JKR. Okay, preparation, mitigation, preparedness, response and recovery. For JKR, I think the kata bencana normally kita boleh tengok in term of the landslide lah. Landslide memang kalau kita cakap landslide je, kita akan tahu terus kita akan cakap pasal JKR. And then mungkin kalau pasal structure ke kan bangunan yang orang kata dalam keadaan yang berbahaya, okay, JKR lebih tahulah. And then JPS, okay, Department of Irrigation and Drainage System, okay, is contribute to all the DRM cycles. So that's mean they need to to prepare during the pre-disaster. Okay, for example flood. Okay, before the flood occurs, okay, kita kena dalamkan sungai, okay, kena put some bund, okay, ataupun kena buat reservoir, for example, to mitigate the floods. Okay, and then prepare to, that's mean when the flood is occur, okay, JPS go to the high risk area and then put their pump. This thing happen, banjir yang berlaku kan. So bila banjir berlaku, dia letak pump. Okay, that's how the JPS respond. And then for the recovery, that's mean after the flood is occur, okay, JPS will sit down with their community, okay, and then try to do some plan to overcome the disaster, supaya disaster tu tak berlaku lagi. So that's how the DRM circle is occur for the JPS. Okay, so saya rasa itu saja pembentangan saya untuk sesi pada hari Ahad ni, dan saya harap all my sharing knowledge actually is become useful to you guys in helping you guys to to do some disaster risk reduction and management. And if you have any question, okay, related to my section, okay, at the end of the class is around 4 to 5 p.m. Okay, we have a discussion. So any question related to my topic, okay, you guys can ask me during that time. Okay, itu saja daripada saya. Terima kasih for the attention from you guys, dan Assalamualaikum dan salam sejahtera pada semua.